Good morning. Today I'm going to discuss about linear regression, how linear regression works. This is basic machine learning algorithm which is widely used, but this linear regression doesn't use directly. Uh, but yeah, so foundation of every algorithm starts with linear regression only. So it's very simple algorithm. Here I am going to discuss about theory and practical also. So what is actually linear regression is. So linear regression analysis is used to predict the value of variable based on value of another variable. Like here you can see y is equal to beta naught plus beta 1 x plus epsilon. So here beta naught and beta 1 are the weights, or here beta naught is the uh, intercept and beta 1 is the slope. Okay, it's very equal to y is equal to mx plus c. Okay, and the variable you want to predict is called dependent variable. Here is y is the dependent variable, and variable you are using to predict the other variable value is called independent variable, that is x. Okay, so how this algorithm works? So before going to that, we have some assumption. The linear regression, while we are building linear regression algorithm, we have to consider some assumption. So there are 5 assumptions basically, but it could be more, but these are the strong. So regression is nothing but having relationship. Relationship is nothing but x with x, that is independent variable with independent variable, or independent variable with dependent variable. That is a regression or relationship. So linear relationship is nothing but it should have linear relationship. That is nothing but when x is increasing, y should increase, or when x is increasing, x1 also increasing. So this is just a relationship. So when we are considering regression, so linear relation should exist. So linear relationship means here, if I am considering only x and y, that is dependent and independent variable, they should be a relationship. Okay, it must have relationship. If it is not having relationship, then model will not predict proper values. Okay, so when x is increasing, y also increase. Okay, multivariate normality means like if you have x1, x2, x3 and y, that is independent variable and dependent variable. So all x1, x2, x3 should have same value. Same value means like in case of if I am considering salary, experience, so salary has huge amount of number. Like digit has very like 6 digit, 5 digit numbers. But in experience, if you consider, maximum 2 digit will come. Minimum will be 1, maximum will be 2. So in order to make normality, we use some pandas library and all this thing, and we try to make it normal. Okay. In case if it is uh, single variable, okay, we don't need to do any normality. But if you have multivariate, like more than 2, we need to do uh, yeah, I got some disturbance. I got call. Sorry for that disturbance. Multivariate normality is nothing but if we have more than one variable. So in order to make prediction properly, we need to make every number should be between 0 to 1 or -2 to minus plus 2. Okay, like that we have pandas library and all. So some statistical library are available. So that will take care of that particular normality. Okay, no little multicollinearity. So like if we have multivariate, in case of a linear relationship, in case of a simple linear algorithm, we don't require any we don't have multicollinearity because we don't have multivariate. But if it is single, it doesn't bother us. So we have only x and only y. But if we have two uh, independent variable and one dependent variable, so these two independent variables should not be relation to each other. Like x1 should not depend on x2, or x2 does not depend on x1. Like if x is increasing, y is increasing, x1 is increasing, x2 also increase. It should not happen. If it is happening, it should have very little. Like we measure collinearity from 0 till 1. So if it is 0, it has no collinearity. If it is 0.1, it has little multicollinearity. Okay, but if it is near to 1, like 0.9, 0.9, 0.8, so it means it has strong collinearity. So we take care of that by using some statistical analysis. No need to go in deep for this. So multicollinearity, again, that algorithm is completely different. So homoskedasticity. So I have written this homoskedasticity, how it is pronounced. So also called homoskedasticity. Refers to a condition in which variance of the residual or error. Okay. So whatever we are getting error, it should have constant. Okay. Variance should not vary much. Okay. It should have constant variance whenever we are getting any error. If it has more spread of error, so we might not get proper prediction. Okay. Okay, the math behind linear regression. So in this case, if I'm considering simple linear regression, I have only x and y. This is dependent variable, y is dependent variable, and x is the independent variable. So x is the independent variable, nothing but I have continuous data. So regression always have continuous data, that is 3, 3.2, 3.64. So those concepts comes under statistical. Before going to learning any machine learning algorithm, you should have some concept clear in statistics. And why will always have continuous data only. So depend upon why only we decide that it is regression problem or classification problem. So here, if we are discussing about regression analysis, which is simple linear regression. So x is the independent variable and y is the dependent variable. So goal, we want to find the mathematical formula that links x to y. So we have y is equal to f of x. So y, we have function which is depend on x. Okay, x is the independent quantity and y is the dependent quantity. So y is always will be function of f of x. Function of x. Why? Because when x increase, y will increase or decrease. It depends on positive or linear relationship or negative relationship. So in this case, if I am considering this is a positive relation, if I am considering that here, yeah, it is not visible here, but this is x-axis and this is y-axis. So y, I have dependent variable. Whenever x is increasing, like from 3 till reaches 4, y also increasing here. So in before table, we can see when x was 3, y was 5.6. When x was 3.2, y was 6.1. So when x is increasing, y is increasing. That is, it holds positive correlation. Okay, and this is the simple formula. Like, so that was scatter plot. What we saw. This is the same plot which we have seen before. Okay. So y is equal to ax plus b. Here y is independent variable again. A is the some slope and b is nothing but a constant or intercept we see. So if we are discussing linear linear regression or algorithm, we always try to take a as a beta naught, a as a beta 1 and b as a beta naught. Okay, so we always interpret this y is equal to x plus b in the form of y hat. I haven't mentioned it. Y hat is equal to beta naught hat plus beta 1 hat x plus some error. Okay, so where a and b are nothing but a constant, or beta naught, beta 1 are constant, or weights of the particular equation. Okay, so here we see if you have this type of dot, so we always try to find the best fit line. Best fit line means the line should pass all this error, but in practical it is not possible. But that's why we have statistical analysis. So we try to make best fit line. The line should pass through all this dot, or it should be touching. So the algorithm tries to take maximum touch, or it should pass exactly middle of this. That's the constant error we discussing like homoscedasticity. It should not pass like this. Here the orange color line and the dots are here. So actual data is lying here and my predictive line or predictive dots are here. So if you're considering from this point to this point, error is very high. From here to here, error is high. Like this, all the error is high. If you are considering this red line, this is also not best fit. So what we do, we have some formula. So how we find the beta naught and beta 1x? So this is the formula. Summation of I minus y mean, xi minus x mean, xi minus x mean whole square. So this with this equation, we can find beta 1 and with this mean and mean plus this beta 1, we can find the beta naught. Okay. So in this way, we can get the y prediction. After that, we need to find the error. So how do we find the error? There is a loss function that is nothing but yi minus y mean. Sorry, prediction, yi minus y prediction. So if I am considering only this part, yi minus y prediction, that means I am calculating only single point error. That is nothing but x to y. When I predicted y, okay, when I predicted y, so I should minus this 5.6 to predicted value, 6.1 to predicted value, 6.8 to predicted value, 7.8 to predicted value. That is nothing but a loss function. So in this way, we calculate the error. And if I want to find the mean of all error, then I have to take mean squared error. So like that, we can find the error. Okay. So this is how we calculate. These are my actual data points. So these points are completely different from above example. There I have only 4. Here I have 6. You will understand how this error will get calculated in practice. So I am going to implement that practical part also. So generally we have these dots in our actual data point. Y1 when x1, y2 when x2, y3 when x3, y4 when x4, y5 x4, and x5 x6 when sorry y5 when x5. Okay, like that. So through that calculation, by putting that value in yi minus y mean, I got this line. Okay, this is the best fit line we consider. So from here the things homoscedasticity will work. So from this line, error should be constant. Okay, if it is not constant, it should like maximum point should be having some around. Like if this error is 3, this should have 2.9 or 4.3.2. Like that error should have. Like in this case, if I am considering this 3, it has like 2. That is very much. But every occurrence should not be like 2, 2, 2, 1.5. It should not happen. If it is error is like 3.1 or 2.9, that is okay, 0.1, 0.2. So we consider that is the best fit line and we have predicted properly. So make it again smooth. There are some gradient concept also is there. So as of now, we are not discussing that. This is it. Thank you. I am going to implement this in practical. Okay. So here, generally we use this Jupyter notebook, and we can run Python language here. So this is nothing but this is the Python language we are implementing it. Okay. So NumPy array holds some calculation library. Pandas also manipulation of data. We can plot, we can change the column name, all these things, manipulation related things we can do related to data set, or this is my data set, or this could be Excel sheet, this could be CSV file also. So here we are using our own data set and converted into data frame. Okay. So NumPy holds for array like situation, okay, or calculation related. Okay. So NumPy is very huge library and Pandas also huge library. This matplotlib always used for matplotlib always used for plotting purpose or visualization purpose. So how this will happen, we'll see. So import NumPy array as np. NP is nothing but alias name, and pandas is nothing but this is library. I am calling with PD. I can't use like here NP numpy dot array. Okay, I don't want to use numpy. I want to use NP. So I will give you reference name or alias name. So in this way we can do. Instead of NP, we can use numpy also, numpy dot array. Okay. So this is my list. First, we have list. What is list? We should have concept clear in Python only. Okay. So this is list. List holds any data type like string, integer, float, boolean, all this kind of data types it can hold. And this when I'm converting into numpy array, then after that only I can make a data type, sorry, data frame. Okay. If I'm using direct list, I cannot convert into list into data frame. First I need to convert into this array dimension. Okay, this is single dimension, this is also single dimension. So together if I'm adding this, it becomes two dimension. Okay, so exp is nothing but experience, salary is nothing but salary, we know. So when I have 2 years of experience, I should have 50,000 salary. When I have 4 year experience, I should have 70 years of 70,000 of salary. Like this, it is varying. Okay. So our goal is to find experience is the independent variable, salary is the dependent variable. Okay. So when we have experience, then only we have salary. So our aim is to find if I have this much of experience, I should have this much of salary. So goal is to find salary. Why? Okay. So if I'm passing this independent variable, I am predicting some around 49,000 or 51,000. I should be getting this near value. If I'm getting more, that is not predicting properly. Like I'm getting 50,000 instead of 50,000. If I would get 60,000, my model is predicting. That is not the good things. So we need to do something. Okay. So here, this is the shift enter is the running this particular shell. Now, I have this numpy array. I'm converting this numpy array into data frame. How we do? PD dot data frame. This is the dictionary I'm passing. So this is the key and this is the value. This is the key and this is the value. So whatever the string form is there, it will highlight here. Okay. If I'm considering this experience and this is the salary. So earlier it was exp. So it will convert it into experience. Okay. So it becomes experience. I don't want huge name, so I'm keeping simple things simple. So this is my data frame. Now I want to do some manipulation in this. If I want to do, okay, we can do manipulation. Like I don't want this line, this 150. This is outlier. We can consider 120. We can consider outlier. Outlier means that we have data repeating 50, 70, 50, 70 in this range only. From 40 to 70 it is ranging. But sudden, if 150 is coming, that is outlier. That is not belongs to dense data, okay, or dense population, we can say. We can consider. So if I don't want this, I can remove this data also. Okay, that is the manipulation. So next step is to plot. So this is the normally scattered plot. Through this scatter plot, we can get where the outlier is existing. Okay. So here, if I am considering above 14 or above 140, I am getting some outlier. We can remove. So this is the way we can plot. PLT. PLT is nothing but matplotlib. This is the library matplotlib.pyplot as PLT. Okay. Here we can plot. So PLT scatter is the plot name, and we need to pass the exp and salary. What I passed here? This one, exp and salary, numpy array. Okay, I can pass this data also, but as of now, time being, I can't do this. So this is the thing, and this is the simple formula which we have discussed here above in our PPT. So again, now we have made data frame. Now again, so in order to get this beta 1 and beta naught, how can we do? Simple calculation. First, I will show you how manual calculation is. So instead of exp salary, which is a numpy array, I am taking this as x and y for simple calculation, okay, for simplicity. So we have formula. What is that formula? if I'm considering this part, okay, I want to calculate beta naught and beta 1, okay, and I want to put this value in this. So here I am getting yi minus y min, xi minus x min. So here x is the data point, x min is the mean of that particular array. Okay, so x will be the 2 and mean will be the 2 plus 4 plus 3 plus 9 plus 12 plus 14 divided by all this occurrence. 1 2 3 4, like here we can see 9 means 10, 10 divided by whole data. We have to add this 2 plus 4 plus 3, then we'll get mean. Mean, that is nothing but 2 minus mean, 50 minus that salary, that is nothing but uh, y minus y min. So same thing we have to do. X is the data point, that is 2. Mean is nothing but whole numpy array mean. Y is the data point, that is 50, and y dot mean is nothing but whole data point mean. Okay, the whole data point means whole salary mean. Okay, whole salary mean. So in this way again, x minus x min whole square. So I have given this name. This separately, numerator and denominator I am calculating separately. So numerator will be this one, sum of summation. Okay, SUM is nothing but a summation, and n is nothing but a here denominator. So if I do m by n, I am getting b1. Okay, I am given b1. So that is nothing but beta 1. And if I am doing beta 1, same thing is then consider is continuing. Okay, and beta naught. Beta naught, how I am calculating here? Sorry. Once I know the beta 1, what's the formula? Y means minus beta 1 x mean. Okay, so I know y mean x mean also, and I know now beta 1 also. Okay, in this way I can get the calculator of beta naught beta 1. Okay, y dot mean, or else we can do yeah, y dot mean separately we have to calculate, and beta 1 into x dot mean. In this way I got beta naught. So if I put this value in this value, where is my equation? In this equation, if I put in this equation, beta naught I know, beta 1 also I know. If I put x is equal to 2 here now, okay, if I put x is equal to 2, what I will get? I will give you this name as the p value. So what will be my p value? Here in this case, p is nothing but 2. Okay, that is the independent variable. So if I'm passing 2 as a value here, I might get y prediction. Okay, y underscore right. Okay, beta naught is not defined. Okay, sorry, my bad. Okay, that is 44. Okay, this is the 44 I am getting for when I have experience with 2 years. Okay, so it's very near. Okay, uh, according to company he is getting 50,000, but according to statistical analysis we are getting 44,000. So whether this is right or wrong, okay, we can do this concept through like yeah, again we have done manual calculation only. Here we can see same thing, but here car speed is nothing but exp, and this is the salary. Okay. Something is wrong. Okay, I'm not doing this one. Might be my data change, the data frame has changed. Because 1 2 3 4 5 2 4 5 6 7, according to this it was taken data, a little bit confusing. So same thing again, I am passing this data set and I am getting this prediction. Okay, so for that when I pass 2 years in this data set, okay, I am getting 44,070. Okay, like this Like this, if I'm passing 4 here, I'll get 58,000. See, if I'm passing 4, it's a manual calculation. Okay. So I'm getting what I got 33. 1 second. The X has changed actually. Here I need to pass experience properly. Okay. That is 58,000. Okay. Like if I'm passing 4 instead of 4, 3, I should get this value 51. Okay. So how can I get this value? So we have this plotting also. I'm not going with this. Now with scikit-learn we are going to predict the value. So we have data set. Okay. We have data set. Here I am considering X as my target variable, Y as a salary as a target variable, and experience is a independent variable. Okay. So that is nothing but X is a feature, Y is a target. So in this way, you have to apply ilog. ilog will help you to drop the column. Like whatever you want to select, automatically the last one will get not selected. Okay. Data.ilog, all the rows from zeroth column till 1. So if I'm considering this last one, it will get cancelled. Okay. And this 1 minus 1 get 0. So basically we'll get experience on X, and it must have data frame. If it is have series, then we'll get problem. Okay. Then this is our linear regression algorithm. Okay. From scikit-learn, this is also big library for calculation and for importing some inbuilt algorithm. It's very big library. Okay. sklearn dot linear underscore model. From this model, I am calling linear regression. Okay. So same this linear regression holding this formula and all these things. Okay. This formula is holding, all this calculation is holding inside that particular library. So we are getting that through linear regression. And what we have to do, we have to just pass model dot fit x comma y. So I am passing that x and y. What is x and y? This is x, that is the table. Y is nothing but our remaining, that is nothing but y, 50, 70. It is not having salary and all. Only 50, 70, that is nothing but, you understand? So only this value I am passing. Okay. So our model has been built. So now we have to predict the value. So what we have to do? Model dot predict x we have to pass. What we are passing? X we have to pass. This 2, 3, 4, 2, 4, 3, 9, 12. All this, if I am passing one by one, like this, in this, I'm passing 2 separately. Okay. Then 4 separately, then 3 separately. I was passing separately. But if I'm passing data set, in that way only it will work. From behind Python language as well. So in that way it is getting calculated. Okay. So I got 44, 58, like we have seen manually 44 I got, 58, 51 for that particular data point. Same, the result is highlighting. Now I am adding that column to previously what we have created data frame. So prediction I'm adding. So this is my data frame. In that data frame, I'm adding this name of column equal to what this value? Value will be y prediction. So all this prediction will be highlighted here. Okay. So against this. So if I want to plot this, you can plot this also. And before going to plot, we are calculating what's the error. Okay. What is the error? Error is the constant or not. Okay. So if I am considering this, so from sklearn matrix, again from sklearn, this is the library I told you. This is the mean squared error. Okay. If I'm calculating error, 50 minus 44, I'll get some error. That is loss function. yi minus y prediction, yi minus y prediction, yi minus y prediction. I'll get all the values here. Okay. And I'm adding that all value. That is nothing but, here I shown you. yi minus y predicted. Again, whole square divided by n. N means I'm taking that mean. So whether it is giving some homoscedasticity things or not. So we can find this. So 174 is the constant error we can say. Okay. And if you want to find the accuracy, you will get 82% accuracy for that particular data frame. So now we can plot that result also. So R2 square is nothing but accuracy. If I am doing 1 minus R2 square, I might get whole this data 1 minus I might get error also. Okay. So PLT dot scatter data experience. These are the column. These are the column. Okay. We are plotting first actual data. Okay. We are not. This is labeled as the actual. What is actual here? Blue dot. These are the actual point. What is that actual point? Experience salary 254.70. We are plotting this against. Okay. And we are plotting experience with prediction. Okay. Again, with this, what is our prediction data look like? So if you see, we have plotted only scatter point. Okay. This point you can consider, which is in orange color. Now, if I take a line, okay. So we can plot that also. PLD dot plot through this, we can plot the line. EXP, that was earlier point. EXP when we are it's a numpy. Y prediction is nothing but our data. Okay. Label is predicted. It is given. That is line. Color is red. So these are the label. X label is experience. Y label is the salary. Legend will tell this one. And plot dot show. If something is highlighting above this graph, it will highlight that one. Okay. What is this coming? It will highlight. It will hide. If I go with PLD dot show. So this was the implement related linear regression. Okay, thank you. I'm stopping this recording.